So if you see my video, we have here a live system, and essentially we can scan the product that the demo board that we have on that. But before that, I would like to explain about the portfolio, the unit capabilities. Is that okay?
Yeah.
Good. Okay, so let me share my desktop and we can start. Okay. Good. So again, this is our main customer presentation. So I'll go quickly, but just FYI, we are a UK-based company. So all the administration, software development is done in the UK. However, the hardware and manufacturing is actually done in Canada. And what we are offering is something like this. So again, I don't fully know your, let me turn on my, I don't fully know your needs, but essentially the scanners can give you something like that very quickly. In a few seconds, you will get an emission map of sources or your DUT. You will be able to identify sources of emission in frequencies up to 8 gigahertz. So that's essentially what the product is doing. We have several types of product. We have the EMScanner, we have the EMScannerR, and we have what we call the EMPre, which is a bit more solution oriented. The EMScanner and the EMScannerR are scanners, and the EMProbe is a single probe solution with a robotic arm. The scanner's resolution, the EMScanner resolution is 7.5 millimeter. The R version is high resolution, 0.06 millimeter. So if you want to scan high density PCBs or silicons, you need the high resolution. The EM probe, this model that you see on the screen is 0.2 millimeter, but essentially with 3Data's custom solution, you can choose or define your specification, and we will find the right arm for you based on size and other requirements. The difference between the scanners and the robotic arm is that the scanner is flat and very, very fast. And the robotic arm is essentially a single probe solution, but the advantage here or the trade-off is that it can follow the topology of the board. So the single probe solution can go up and down, while the scanner is essentially flat. Again, there's no good and bad here. It depends on your needs. This is the bit more technical data on the EMScanner. So essentially, the EMScanner is an array of 1,218 probes. So each square here is an antenna. And this is our frequency range, 150K all the way to 8 gigahertz. And again, this physical resolution, this is the distance between the probe, is 7.5 millimeter. We interpolate half of that to half of that, 3.75. The scanning area is about the size of a printer page, about an A4. And the maximum radiated power that we can absorb is around 40 dBm. This is the R version. So from frequency range perspective, it's the same range. However, the resolution here is very, very fine. It's sub-millimeter, 0.06 millimeter. And I think the next slide actually shows you the difference between a 7.5 millimeter scan to 0.9 millimeter scan. So here you can start seeing internal structure of the silicon and see exactly what's going on in a very high resolution. Again, it depends if you need that level of resolution because there is a price difference between the two. But in most cases, for a regular PCB scanning, the regular EM scanner, the 7.5 millimeter, is sufficient. If you're looking for very small DUTs, you probably need the high resolution. This is example of the EM probe. So again, there is a lot of flexibility with this product because again, we define that more as a solution. You can choose the probe types. We do have our own probes, but you can essentially use any probe that you want. And again, size and the ability to follow the topology and actually set a certain height per location, the z-axis is key advantage. The trade-off is time. A single probe moving solution is always slower than the scanners, but sometimes it's needed. This is the setup. So usually the scanner will be connected either via LAN or USB to the software, to the PC. And then there is an RF cable goes to the unit from a spectrum analyzer. Spectrum analyzer also connected to the PC. Essentially, that's the setup for all our products. I think we discussed that. So essentially what we're offering is in-depth PCB analysis and verification. You can pinpoint the location of emissions from your DUT all the way to up to 8 gigahertz. This is the board that I have here on the scanner, and I can show you exactly what we will see. But first of all, I'll explain what we see here. So this is an RFID board. Here in this section, it's a DC to DC converter, so I can power it from the wall, or I can power this board from a USB. Now, when I'm powering the board from a wall socket, the DC to DC converter is engaged, and this is what we see here. So it's about 125 megahertz of switching time of the clock of the DC to DC. And all this mountain here, all that is coming though to the DC to DC. When we're actually using the USB power here with the battery, you can see a really nice, clean operation. Now here you can see the running clocks. We have a 27 megahertz oscillator here, and we have a 32 megahertz oscillator in this side here. So while I will scan that, you can actually see everything, and we can analyze the board itself. Any questions so far?
One question, how sensitive it is, like lots of components are there on that PCB. So will it catch the signal or interference from other components, or how much it is sensitive to particularly detect a component?
So it is sensitive again. I'll show you actually the software. I'll done few scans already. So you can see the noise floor is around minus 100 dB. So essentially it's pretty quiet and pretty sensitive. Everything that I would say around minus 80, minus 90 dBm, we will be able to capture and of course show it. So everything is connected. First of all, the first thing that you need to do, this is the live software now. So let me open the camera here so I can show you. Just a minute, I need to set up the camera, sorry. I'll just turn off my camera from here. And then you will be able to see the camera here. Okay, so this is the board that I have here on the scanner. So everything is connected. You can see that I'm powering the board from the wall socket. So the DC to DC converter here, you did see my video, right?
Yeah.
Okay,
Yes,
so
I'm
the
able to
DC
see.
to DC converter here is engaged. So now we can just place it on the spot. We will go back to the software. So here we can define the area of scan. Here, the frequency range. We support most of the spectrum analyzer out there. At the moment, I'm using the Signal Hound BB60. This is the spectrum analyzer that's connected. I selected the area, and essentially that's it. I can start the scan. So it will take a second to program the spectrum analyzer, and this is how it's done. So we actually scanned everything. I'm actually doing here 2 scans for interleave mode, and you can see the speed of everything. So now you can actually zoom into a certain location and start manipulate the software and see exactly what's going on, see exactly where this emission is coming from. If I'll go to the top window, I can start, that's the frequency range, and I can start looking into frequencies. So as I mentioned, in this area, the oscillator is 32 megahertz. So I can actually select the 32 megahertz, and you can see that it's coming through here, from here. So we can identify essentially the oscillator area and everything that actually works on 32 megahertz. The 27 is actually controls 27 controls this area here. This is the controller that controls the RFID. And if I'll reset this thing and we will choose the peak here. Oh, come on. This is the antenna, so you can see the 13.5, which is the emission of the RFID antenna. And this, again, as I mentioned, this is actually the noise coming from the DC to DC converter. And this is all live. So if I'm now disconnected and take a battery, connect battery, take the battery cut.
Put your camera back.
Oh, let me put my camera back on. Okay, so if I'll disconnect it, I'll disconnect the power, and so now it's running on battery power. And so you can still see the LED and everything, but we can do exactly the same scan again. Nothing changed from setup perspective. And now we can scan the same equipment, the same DUT. So now you can see that the environment is much, much, much quieter. We can definitely see the frequencies, the key frequencies. We can see the harmonics of everything. So if I'll select this area, I still have the 30, the 32 and 27. We can see the 27 megahertz being generated the same place. And you can actually see that it's traveling through the cable all the way to the other side. Not very good thing. Then I can select the 32. So we can see that the 32 is being generated here and traveling across the cable to the other side. The problem with the 32, or with this design, actually what we want to show, is that there is no coupling or decoupling between the cable to the RFID and to the RFID antenna. As you can see, the 32 megahertz goes over the cable all the way to the other side and also to the antenna. So it will be emitted by the antenna as well, which is actually not a very good thing. Because again, for RFID, it's not important, but if you have some kind of a modulated signal here, it will cause problem with the modulation and probably, bit error rate for the receiver. Here you can see the harmonics of everything. So I can zoom in to a certain frequency. And this is, again, 216. This is the 27 megahertz harmonic. And this thing is also bidirectional. So I can select a point here, and I can see the frequency response of that specific location. Or I can select a certain frequency, and I can see the frequency distribution on the image itself. So it depends what you want to see. Here on the left side, all your scans are being saved, so you can revisit them. And you see now the battery is connected, but I can still go back to the scans that I just took a few minutes ago and analyze it. So the information is available. And so again, this is the 125. It's coming from the DC to DC converter, and we can analyze exactly how it's being distributed across the board. This one is also reaching the antenna. Now there's many more features. Of course, you can export the data. You can set or limit the amplitudes to a certain level to capture only certain amplitudes. many things that you can do with software itself. There is an API, so can automate all that via Python or something. But that's essentially the functionality of the device, of the unit. It allows you to capture the emission from DUTs very quickly in a very accurate way. Questions?
Yeah, this is how we can compare with this one that you have previously. We have robotic arm as well. What is in difference in between this one and that one?
What do you mean between this one to the robotic
The
arm?
robotic arm we have, you have shown previously that you have robotic arm here, EMC
Yes, so
scanner.
the
Yeah.
robotic arm is running on the same software exactly. When you go in here, if I had a robotic arm, you can see here or in the bottom, you can see that connected is the EMScannerR. A robotic arm will appear here and you will be able to select it and do exactly the same scan. The key difference between the scanner and the robotic arm is time. With robotic arm, again, it's a single moving probe. It's a single probe moving, so it will take more time to scan in high resolution. The advantage of the robotic arm is that you can design and use different types of probes, while with the scanners, you have a flat surface, very fast, but it's kind of a very complete product. There's not a lot of adjustment that you can do with it. If, again, depends on your use case. If you need the z-axis, then probably the solution is a robotic arm. But again, you will pay with time because it will be slower than a scanner. You saw how quickly we can run scan with the scanners, right? So that's the key difference. The scanner is essentially, yeah, robotic arm will not be able to do the scan that quickly. So that's the key difference, essentially. It's an array of probes compared to a single moving probe. Both are valid, right? There's no good and bad, but it's different use cases.
Okay. Both runs on same software, correct?
Yeah, this software can handle both.
The feature of the software, can you explain a little bit more? Like what all we can do with the software?
So the software essentially control the scanner that connected, either the scanner or the robotic arm. First of all, you have here kind of three modes of operation. So this one is the first one, and this is a frequency only scan. And the idea here is you don't need to select the entire board, but you just select a certain area to see what kind of frequencies are present. Now, analyzer, again, we will set the frequency RBW 100. I think it's a bit too much power for that, so let's reduce that to 30. So this is the first mode of operation. This is kind of a spectral scan only, just to identify the frequencies that are present. Now you can select a certain frequency, like you can see the peak here, or for example, this guy here, the 32, I can select it, and I can run special scan at the selected frequency. So this one is a scan of only that frequency. So it's a single frequency scan. And here we can select this entire area and run the 32 megahertz scan. So the next mode of operation, the one that I showed you, is this one. This one is the combined one. Now, this one is the slowest, but contain a lot of information because you can select a certain frequency, or you can select a certain location and see the response of that location. Now, you can also copy image to clipboard. You have you can export the test, export all to CSV, export just the peak to CSV, so you can save that or take that to another analysis tools. And another thing is actually report generator. So during normal operation, you will do a lot of scans. Not all of them are relevant. So if you will click here, you have this report generator. You can go in, you can select few scans that you want, and then click generate the report, and the software will create a template of report for you. It's a Word document, and we will embed the data. So where is it? This. So now you can go in and add your comments or whatever you want to do. So you will have a timestamp and exactly what you scanned and how it looks like. And then you can go in and add your notes. Or again, to use another third-party tool, go over the CSVs and analyze the information. But essentially, the software provides a visual representation of the frequencies. So that's the idea.
Okay. Is there any configurable option so that we can add like my DUT got passed or failed, or how to identify it? Any limit line we can set it here in the software to identify automatically that device got failed or passed based on the
No,
emission.
there's no mathematical way to determine. So this is a diagnostic and debug tool. There's no way to determine if your device will pass or fail based on near field. It's the far field is when you go to a chamber, you will get you failed at that frequency. That's it. Now you need to understand where it's coming from, and the investigation is being done in the near field. But to predict if you will pass or fail based on near field measurements, there's no way to do that. There's no mathematical way to do that because PCBs are very complex animals. You have, different level of emissions, different frequencies, different directions. There's no phase coherence. So there's no way to calculate the far field from a PCB. We can do that for simple PCBs or from antennas, for example. This is doable. But from complex PCB, it's not possible.
Okay.
If you have, a single trace on a PCB, we can do that. If you have just, few layer and fairly single frequency, it's doable. But for the modern PCB, many components, many power levels, many direction of the current, there's no mathematical way to do it.
Okay. Got it.
So we have the unit here. If your colleagues would like to see another demo, so we have everything set up. You can just set another time with us. I think this meeting was recorded, so of course we can share the recording with your colleagues.
Yeah.
Yeah. And I think that's it from my side. Cornell, do you want to add something?
Yeah, so meeting's recorded, so I'll send it, to everybody who said they would join for the meeting. Has that answered all your questions, Anil? Is that making it clear and you can see how it can benefit your business?
Yeah, I got like basic idea I got, but I need to discuss with my team members like the
Okay,
requirement and all those things. Yeah.
okay.
Yeah.
Okay. Yeah, and as Yura mentioned, after they've seen the recording and they're not clear and they want to, have another meeting, by all means, just get in touch with me and I can set that up again.
Yeah, sure. Thank you.
Okay. So I'll be in touch then and hopefully we'll get to talk to each other soon.
Sorry, didn't get last point.
I said thank you for joining and
Yeah,
hopefully we
okay.
will get to talk to each other soon.
Yeah, yeah, sure, sure. Thank you from my side. Like, thank you for the presentation.
Okay, no
Thank you.
worries. Thank you. Bye.
Bye. Thank you so much.